Question number 7. The diagram below shows two similar triangles. If the tangent of theta is 3/7, what is the value of x to the nearest tenth? That, ladies and gentlemen, is the objective. And I see a moment ago it says that these triangles are similar, and the significance of that is that sides are proportional. So we know that the short side of this triangle corresponds with the short side of that triangle. Likewise, the hypotenuse is proportional to the hypotenuse, and the long side is proportional to the long side. So what we're going to do is we're going to set up a proportion to solve for x. What else do we need to know? We need to know our trig ratios and recognize that if we're talking about the tangent of theta, we're going to be thinking about the opposite side over the adjacent side. And if we're looking right here, I know that this is the opposite side. This, however, this blue side is not the adjacent side because it's the hypotenuse. This is the adjacent side. So let's label this appropriately. If it's 3/7, this is going to be 3. This is going to be 7. And now we need to set up this proportion. So it's going to be 3/7 equals what over what? Well, I know that if it's going to be red over green equals red over green, it's going to be 2.4, the short side over the adjacent side, which is simply x. Beautiful. All right. And so when we cross multiply, we're going to get 3x equals 7 times 2.4 gives us 16.8. Beautiful. And then we're going to need to divide both sides by 3. And when we do that, 8 is 5.6. Beautiful. And that, ladies and gentlemen, is our answer. And this is option number 2. Question number 12. Given the right triangle in the diagram below, what is the value of x to the nearest foot? So we're trying to figure out the value of x, which is right here. All right, well, how do we approach this? I know that if it's a right triangle, then we can use our trig ratios. And I'm going to think about the relationship of this side and this side to the angle that we know, which of course is 40 degrees. Well, 14 feet is the adjacent side. X, of course, is the hypotenuse. So of these three options, we're going to be doing cosine. And so let's set this up and let's solve for x. So I know that it's cosine of 40 equals what over what? It's adjacent over the hypotenuse. So we're going to do 14 over x. Beautiful. And then we can simply cross multiply, and we can put this over 1. And when we cross multiply, it's going to give us x cosine 40 equals 14. Beautiful. And so what we need to do is divide both sides by the cosine of 40. Beautiful. And when we do that, x equals what? Approximately 18, which is option number 3. Question 23. In the diagram below of triangle ABC, angle ABC is 90 degrees. It's a right angle. I see that AC is 12. I see that AD is 8, and we've got altitude BD drawn. What is the length of BC? So this is our objective right now. Well, the first thing I know is that we're going to be creating a proportion to determine what BC is. And to do that, we're going to need to establish similarity between this triangle, this small triangle right here, and the overall big triangle. And we can do that because a small triangle has a 90-degree angle. Likewise, the big triangle has a 90-degree angle. And they both share angle C. And so that's, of course, reflexive property. So we've got angle similarity. So let's set up this proportion. Before we do anything else, we're going to need to figure out what the short side is of this leg right here, of this triangle right here. And we know, of course, that CD is 4. And we can figure that out. We know that the entire length of the hypotenuse of the big triangle is 12. 12 minus 8 gives us 4. Tremendous. So let's set up this proportion. So we'll set it up like the short leg of the small triangle over the hypotenuse of the small triangle equals what? Well, we don't know what, if we're looking at the big triangle now, we don't know what the short leg is of this triangle, so we're going to describe it as x over the long leg of this triangle, which we know is 12. Does that make sense? So once again, very quickly, we've got short leg over hypotenuse equals short leg over hypotenuse. So that's the proportion that we set up. Now we're going to simply cross multiply, and I know that x times x gives us, of course, x squared. I know that 4 times 12 gives us 48. And so what we're going to do is we're going to isolate x, and we're going to take the square root of both sides. So now we've got x equals the square root of 48, and we can simplify this. We know that, is there a perfect square in radical 48? There sure is. So we can set this up like radical 16 times radical 3 equals radical 48. And because 16 is a perfect square, I know that we can simplify this to simply 4 radical 3. Is this an option? It is. It's option number 2. Tremendous. Question number 23. Here we have right triangle ABC and altitude BD. The question says, which ratio is always equivalent to cosine of A? So one of the things I know is that whenever we have a right triangle, as we have here, with an altitude formed, as we do in the case of BD, that it creates 3 similar triangles. So we know that this small triangle is similar to this medium-sized triangle, which is similar to the overall large triangle. And so what we're going to do right now is we're going to diagram those triangles right here. And what do I know? I know that if BDC is 90 degrees, then ADB is also 90 degrees. So I'm going to color code that right angle like so. And this, of course, is ADB. And here we have the medium-sized triangle, which is BDC. Beautiful. And then we got that large triangle, which, of course, is ABC. All right. So again, the question says, which ratio is always equivalent to the cosine of A? So one of the things I remember is that when we're thinking about the cosine ratio, it's always adjacent over hypotenuse, right? So let's think about this. Which ratio is always equivalent to the cosine of A? So here's the cosine of A, and let's indicate that like so right here. So this is the cosine of A, and because these triangles are similar, I know that angle A in the small triangle is congruent to angle B, and the medium-sized triangle is congruent to angle A in the large triangle. And so now what we need to do is we need to think about, okay, which ratio is always equivalent to cosine of A? So adjacent is this side right here, and the hypotenuse is this side. So the cosine of A, in the case of the small triangle, is AD over AB. And then if we're thinking about the medium-sized triangle, the cosine of B is what? It's this adjacent side, which is BD over CD, or BC. And lastly, we're going to figure out what the cosine of A is for the large triangle. And I know that, again, it's adjacent over hypotenuse, so it's going to be AB over AC. Amazing. And so now when we take a look at these 3 ratios, AD over AB, BD over BC, and AB over AC, do these match any of our 4 possible answers? Well, I know in the case of AD over AB, nope, there's no match. Likewise for AB over AC. However, I recognize that for cosine B, BD over BC, that is an option. In fact, it's option number 2. This is the correct answer.